In this video, we will go over some of the basic derivatives. So first of all, if f of x is a constant function, then the derivative is just 0. You can see this by graphing it. Then what's the slope of the tangent line? It's just 0, but you can also compute it. It would be the limit as x goes to a of this difference quotient, but here it's a constant function, so you just get 1 minus 1, which is 0. And then when you take a limit, it's still 0. What about f of x equals just x? Then let me write a couple different notations for this. F prime of x, which is d dx of x. Well, the limit as h goes to 0 of f of x plus h minus f of x, or the limit as t goes to x of f of t minus f of x divided by t minus x. So they're all sort of the same thing. I mean, equal signs everywhere. Well, let's just compute it using this one. This will be f of x plus h is just x plus h because it's just the identity function. And then the x's cancel. You have h over h. H over h is just 1 as long as h is not 0. And we're taking the limit as h goes to 0. So h is not 0. And so this is 1. So this derivative is 1. So we just computed the derivative for the 0th power, the 1 power. So you'd think we would do the 2 power, or squared, but we can do a little bit more general. Let's find the derivative of x to the n, where n is some positive integer. So we set up this limit, the limit as t goes to x of t to the n minus x to the n divided by t minus x. So to compute this limit is factor out an x to the n and factor out an x from here. So we can rewrite this as something like this. Now if we let t over x be z, then we can rewrite this part as z to the n minus 1 divided by z minus 1. And this is a famous formula. It's the finite geometric series formula. 1 plus z squared plus z to the n minus 1. You can verify this by just multiplying this to here. And so here we'll get that it's x to the n minus 1 times 1 plus t over x squared all the way to t over x to the n minus 1. If we multiply the x to the n minus 1 inside, we get x to the n minus 1 plus x to the n minus 2 times t plus x to the n minus 3 times t squared. Right? So each time you have an x and x squared, so it subtracts one more from the previous. Now in the limit, we're letting t go to x, so we can exchange all the t's to x's, which means these all turn into x to the n minus 1. How many of them are there? Well, there's going to be 1, 2, all the way up to n minus 1, plus one more. So there's going to be n of them. As t goes to x, then we get this. And so we get that the derivative of x to the n is n times x to the n minus 1. So sometimes this is called the power rule.